Hey, what if I told you that there's a secret world hidden inside, well, everything around you? Seriously, from the chair you're sitting on to the air you're breathing, it's all part of this incredible hidden story. And today, we're going to pull back the curtain and see what's really going on. So, let's just start with a quick question. Look around you for a second. Is the air you're breathing matter? What about a solid rock? Or, say, the juice in your glass? Well, the answer is a huge yes to all three. And by the end of this, you're going to know exactly why. Okay, so here's our game plan. We're going to kick things off by asking what matter even is. Then we'll dive right into the world of solids, the flow of liquids, and the total freedom of gases. We'll even see how they can change from one to another, and then we'll wrap it all up with a big recap. Sound good? Let's do it. First up, the biggest question of them all, right? What is everything actually made of? It sounds like this giant, super complicated question, but you know what? The answer is actually pretty simple. It's all made of matter. And what's matter? It's really just the sciencey way of saying stuff. You know, anything that has mass, which basically means it has some weight to it, and takes up space. So from the tiniest little ant to the biggest star in the galaxy, yep, it's all matter.
All right, let's kick things off with solids. They're the most rigid, the most dependable state of matter. I mean, you're probably touching a solid right now. So what exactly makes a solid a solid?
Well, the main thing you gotta know about solids is that they hold their own shape. A book isn't gonna suddenly pour all over the floor, right? And a rock is gonna stay a rock when you pick it up. An ice cube keeps that perfect cube shape, well, at least until things start to heat up. But we'll get to that later. But here's where it gets really cool. What's happening on the inside? If we could zoom way in, we'd see that a solid is made of these tiny little particles, all packed together in a super neat and tidy grid. Now, they're buzzing with energy for sure, but they're basically locked in place. All they can do is just kind of vibrate and wiggle right where they are. So what happens when those particles get just a little bit more freedom? Well, that's when we enter the flowing, sliding world of liquids.
See, unlike a solid, a liquid is a total shapeshifter. It doesn't have a shape of its own. Nope. Instead, it just flows and takes the shape of whatever you put it in. Just think about pouring water from a bottle into a glass. The water just perfectly molds itself to its new home. And this visual shows us exactly why that is. If we zoom in again, we can see the particles in a liquid are still pretty close. They're still buddies, but they are not locked down anymore. They've got enough energy to slip and slide and just glide right past each other. It's that freedom to move that gives liquids that amazing ability to flow.
Okay, so we've had packed in solids and we've had flowing liquids. What do you think happens when we give those particles ultimate total freedom? Well, we get the wild and free world of gases. Gases are literally all around us, and they are the ultimate escape artists. They don't just take the shape of their container. They expand to fill every single nook and cranny. You know, the air in a balloon pushes out in every direction, and the steam from a kettle just vanishes into the air of the whole room. And the reason for this is just pure chaotic energy. The particles in a gas are super far apart from each other, and they're moving incredibly fast, bouncing all over the place. Zipping here, zipping there, bouncing off each other. This is exactly why you can walk right through the air. It's mostly just empty space between all those zooming particles. So we've met our three main characters, solids, liquids, and gases. But here's the plot twist. Matter isn't stuck being just one thing. Oh no, it can actually transform. And to see how, let's follow a single drop of water as it goes on a journey through all three states. So let's start with regular old liquid water. If you take away the heat, its particles slow way down and lock into place, becoming solid ice. We call that freezing. Now add some heat back, and that ice melts right back into liquid water. If we add even more heat, those particles get so energized they literally escape into the air as a gas called steam. That's evaporation. And finally, when that hot steam cools down, like on a cold window pane, it turns back into liquid water droplets, and that's called condensation. Phew. Okay, we have covered a lot of ground, so let's bring it all that together for one final side-by-side showdown to make sure everything is absolutely crystal clear.
This little chart here just sums it all up perfectly. A solid keeps its shape because its particles can only vibrate. A liquid takes the shape of its container because its particles can slide around. And a gas fills any space because its particles are just zipping around freely and randomly. See, when you get right down to it, it's all about the particles.
And that brings us to one last little challenge for you. Now that you're basically a particle expert, take a look around your kitchen. Besides water, can you think of anything else that can change between these states? Give it some thought. This secret world of matter is everywhere. You just have to know how to look for it. Thanks for joining me.